Hello, this is Brian Raya with assignment number 2 for the physics class. Assignment number 2 basically covers fixtures and bodies. I'll briefly show off the demo. As you can see, my glass stick figure goes straight through these two wooden planks and only collides with these two glass planks. So that covers the fixture with at least 4 parts, with a resulting shape being concave. Again, it's a humanoid stick body, and it contains a circle and boxes. Apart from that, in the additional task, we can see that it does not collide with these two wooden planks using the category bits and bit masks, but it does collide with these two bottom ones. So what I mainly did for this sprint was I made basically this wrapper class which will take in the image name, the game object, all these other parameters, and it will create the appropriate game object box, sprite, and game object 2D. Since all of this is wrapped in together, there are some default parameters. So position by default goes to 0, 0. In the case that a position is not required. I'll mention that a little bit later. But eventually, after everything's created, we add that game object to our game object manager, and we have a default physics body. The default, with its default parameters, is that the body is static, and its category bits are defaulted to everything, and its mask bits are defaulted to everything. Further down, again, you can see you have the ability to set angle. A lot of this is just a wrapper to make things a lot easier to read. So creating a new sprite only takes about 5 lines now. Here is an example of me physically defining that the category bits. So this is for the glass blocks at the bottom. The category bits are something else, and the mask bits are set to their defaults. Again, these are the two ones at the bottom, and to go with that, when I create the default physics body for our glass stick figure, we have the reverse of this, so that way when the body reaches the glass section, it will collide with that, but since the mask bits are set to default to collide with default, this collision does not trigger at the very beginning. Continuing on, we'll talk about adding additional fixtures to the body. I've added this this function called add to body. So since this original glass block has already created the body, we merely just add this to the body that glass block currently has. So that way we only have a singular body created for this entire composition, which in this case contains 4 fixtures. When you add to a body, you have the ability to define a position, and since you're appending it to the body, this position is basically an offset from the center of the body. So this is right in the dead center. These are the arms. This covers the head. It's about 100 units above the center. And again, these are the left leg and the right leg, respectively. Continuing on, I'll just briefly go through this. So again, I made structs for position, box dimension, and sprite dimension. I mainly did this for readability. I do have enums for the body type, static or dynamic, and I do have enums for the category bits, as well as the mask bits, with the ability to add more later on. Here is the ability to set the angle, the default physics body. I plan on expanding on this further, so the user can just pass in their body definitions, the ones that come with Box 2D, and the ability to add to the body. These are the things that that my class holds. It's the sprite, the box, and the game object for later to be deleted, and the game object to be added to the manager. Going briefly through the CPP, anything that I own gets deleted. I do not delete the body because I do not own that. Going further down, we can get the game object. We can set our angle. So we go into our game object, set our angle. Depending if it's static or dynamic, we create our appropriate body. And we add its default parameters, which were whatever was originally there. When we add to body, again, we ask which body we're adding it to, and we create that fixture and add that to our body. I think that covers everything that was done for the sprint. As I said, we have our stick figure body with concave sections, with circles and boxes, and using our category bits and our bit mask, we can show that we can define specific block types and have our fixture go through and collide with those types. Thank you very much, and goodbye.